All right, good evening, class. Today we are going to be picking up where we left off in class the other day. I think we saw the demonstration with the index card and the wire screen not allowing water to flow through it from an upside down cup. So if we didn't finish the observations and explanations, we'll get to those again in class soon. We're going to move on to trying to understand the three factors that affect air pressure. And I have an acronym that might help you remember the three factors. The acronym is WET. W stands for water vapor, E stands for elevation, and T stands for temperature. And when we're discussing how these three factors affect air pressure in the atmosphere, consider the atmosphere as an open system. W for water vapor. So, key piece of information here, as the amount of water vapor molecules increase, air pressure decreases. So in algebra, we study negative correlations and positive correlations. And this would be a negative correlation. As water vapor goes up, air pressure goes down. As water vapor decreases, air pressure increases. So why does this happen? Water vapor molecules are about the same size as other gas particles. However, they have much less mass or weight than other air particles. So, the water molecules can push out other gas particles, taking their place, and therefore it lowers the density or makes the air much lighter. Consider a water molecule being the weight of a beach ball, and then a bowling ball that's the same size as the beach ball representing other gas particles. So the weight of the bowling ball or other gas particles is much more, even though their size are similar. If you have a lot more beach balls in an area, then that's making that air less dense, and therefore the air pressure is less. WET, the E stands for elevation. Elevation is also known as altitude. So again, this is a negative correlation between the two. As air pressure decreases, altitude increases, and then vice versa as well. So here shows a diagram where at sea level, or 0 kilometers above Earth's surface, the air pressure is 30. And this is 30 inches of mercury that it's being measured in. But you'll notice as you go up in altitude, the air pressure decreases. So why does air pressure decrease as elevation increases? Well, there are two reasons. The farther you go up in the atmosphere, the less atmosphere is above you to press down on. So you can think about it as the fact that there's much fewer molecules in a certain amount of space the further you go up in the atmosphere. This diagram shows a good example. A little section of air blown up into larger view, lots of air particles. Now we have the same size section of air blown up into larger view where you see much fewer air particles in that space. Now keep in mind that when we talked about the amount of gases in the atmosphere, one of them, the most abundant gas, nitrogen, makes up approximately 76% of the atmosphere. Nitrogen makes up 76% of each layer in the atmosphere. However, you can think about it like this. In this section right here, if these are all the particles of air, only 76% of them are nitrogen. Same for this area of air up higher in the atmosphere. So there's going to be much fewer particles of nitrogen, but they will still make up 76% of the air particles in that layer as well. So here is an interesting graphic, but I kind of like it. Here are two students, Marnie and Deanna, that are collecting air pressure readings for a class project. Marnie is recording data near sea level, and Deanna has decided to climb to the top of a mountain and collect information there. So what I like about this diagram is the colors that represent how much air is above each person. So you can see here Marnie has much more air pressure on her because she has this much extra air, and it's more dense air that is pressing down on her than Deanna does. So back to the acronym WET. T stands for temperature. As air temperature increases, air pressure decreases. Again, another negative correlation. Why is this? Well, first you need to understand what temperature is. Temperature is a measure of average particle movement. So think about it like this. If you were measuring the temperature of a certain amount of air, you could measure the movement of the particles, each one of them, add up the total amount of movement, and divide by the amount of particles. That's kind of what temperature is. When temperature increases, it is due to particles moving more. There's been a gain in thermal energy, there's more movement, and so the average particle movement increases. This movement causes air particles to move apart. So when particles start moving more, they move further apart. When the same amount of air particles take up a larger amount of space, the density decreases. So since the same number of air particles have just spread out a little bit, the density decreases, which causes air pressure to drop as well. Is there a place where there is no air pressure? Well, on Earth or in Earth's atmosphere, the answer is no. In space, yes. In space, there's a vacuum, and we do simulate vacuums on Earth, and we will be simulating one in the classroom soon this week, where students can participate. So what is a vacuum? We'll come back to that question later on.